All right, let's go through this worksheet step by step. There. Phosphorus is in the fifth column. Iodine is in the seventh column. So that's 26 electrons we have to work with. P is in the middle. Looks like we're going to have four things around it. I, 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 26, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26. That is perfect tetrahedral because you have four sides, and a pair of electrons can be four sides. If it's 3 and 1, it's pyramidal. Hybridization, S, P, P, P. All tetrahedrals are sp3. Does it resonate? Well, there's no double bond, so the answer is no. Is it a dipole? Well, are all four sides exactly the same? No. You have three shared pairs and one unshared, so no. They are not all the same, so yes, they will have a positive side and a negative side, and the angle comes from your memory, 107 degrees. There's no way around it. SEBR6, the 6 right there tells you what we're dealing with. It's going to be octahedral. And we only have one type of octahedral. When you take AP chemistry or chemistry in college, there will be more than one type. So selenium is in the sixth column. Bromine is in the seventh times 6. So we're talking about 48 electrons. So it's going to be drawn something like this. A Br above, behind and to the left, behind and to the right, in front and to the right, in front and to the left, BR underneath. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. That's it. Hybridization. S, P, P, P. That's it. You've run out of P's. D, D. S, P, 3, D. Does it resonate? Is there a double bond? No. Is it a dipole? Are all the sides the same? Yes, all the sides are Br, so they're all the same. Therefore, no, it is not a dipole. Angle, the in-between here is 90 degrees. Between the top and the middle is 90 degrees. Between the top and the bottom is 180 degrees. So it's 90, 180. That comes from your memory. Carbon normally bonds 4 times. It's going to be bonded 4 times. So this is a stereotypical tetrahedral. With a little wrinkle in that the carbon is not bonded to 4 of the same things. So still tetra, tetra, sp3. Resonates, no double bond, no. Dipole, is it exactly the same on all 4 sides? The answer is no. Therefore, yes, it is a dipole. Angle from your memory work, 109.5. First ion, 5, 6 times 3 is 23, plus one more is 24, giving us erase that, it's not in the right angle. I don't think this is right. Let's go back. Let's draw it over here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We've run out of electrons. Nitrogen's not happy. We're going to have to bond with one of these oxygens. Which one? The answer is yes. All of them can do it. Therefore, this thing resonates. You have three sides. Therefore, it is trigonal planar. Three sides. Trigonal planar. Double bond counts the same as a single bond. Trigonal planar. And it is stereotypical trigonal planar. Nothing fancy. Three sides. Three sides. sp2, sp, sp2. Does it hybridize? Does it resonate? Yes, this one does. One double bond that can flitter around the other oxygens. Is it a dipole? No, no. It is a -1 charge. It does not have two poles. It is only one pole. You can call it monopolar, but it is definitely not a dipole. This is an ion. It does not have two sides. It has only one side. Angle, all TPs are 120. OI2, this one reminds me of H2O in that just like the halogens, H's can bond only one time. So you have replaced the H's with the I's, it's H2O. It's tetrahedral bent. So O, I, I. Tetrahedral bent. See how it's the same thing as water. The only difference is that iodine will require electrons around it, whereas hydrogen does not. Hydrogen is only able to bond one time. Still four sides, sp3. Does it hybridize? Is there a double bond? The answer is no. Is it exactly the same on all four sides? No, you've got two pairs of unshared electrons and two shared pairs. So the answer is no, it's not the same. So yes, it is a dipole. Angle from your memory work, 104.5. 104.5. Ion. 2, 4, 6. We have 6 and then 6 more oxygens. 6 times 3, 24, 20 plus 2 more is 26. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26. Oh, that's it. This is 3 shared pairs, unshared pair. This is just like the first one, tetrahedral pyramidal. Tetrahedral pyramidal. Is an ion. Tet, pure, sp3. Does it resonate? Is there a double bond? The answer is no. Is it exactly the same on all sides? No, it doesn't matter. This is an ion. It is monopolar. It has only one charge. It is -2. It is not a positive and negative. That's it. Done. What did I do? That's what I get for getting worked up. That's from your memory work. 5. That ought to remind you of BIP, bipyramidal. Bipyramidal. And we only have one BIP, but you will have more BIPs in AP Chemistry. So, one on top, one behind you to your left, one behind you to your right, one ahead of you, and one below you. Or something like that. Angles, you've got the 120s. You've got top and bottom 180, and then from top to the middle is 90. Hybridization, SPPP, done with the P's, and now you have to go to D. SP3D. Resonance, no double bond, does not resonate. And is it a dipole? Well, all 5 sides are exactly the same, so it is exactly the same. Therefore, no, it is not a dipole. Beryllium, alarms going off. Beryllium is a metal, but beryllium can act as a non-metal because its electronegativity is high enough to be able to bond covalently, but beryllium only needs 4. It's an exception to the rule. Perfect. Linear. Linear. There are other linears, but they belong to different families. You will learn that in AP Chemistry. SP, SP. Resonates. Is there a double bond? The answer is no. Is it exactly the same on both sides? The answer is yes, therefore no. Angle, 180. 180. Goodbye.